The pregnant mother and the fetus share the same alcohol level in their bodies. Symptoms derived from this damage have a name: fetal alcohol spectrum disorder, or FASD, and it has no cure. Children with FASD have basic cognitive difficulties, are socially rejected, victims of harassment, and easily vulnerable. At first sight, it is an invisible disability. However, it is a totally visible reality for their social environment. But people with FASD are the ones that suffer the most. Did you know that all of this is 100% preventable? In Spain, 6 out of 10 pregnant women consume alcohol. If FASD has no cure, but it is 100% preventable, why do we not do something? Some countries have already done it. Now it is time for us to act.
Actually, it was this kind of information, it was my first approach to this problem till I was conscious about that. So, thus I decided to put a goal. Why not use the technology to democratize the knowledge of the health sector and medical field, to put a diagnosis tool in every mobile phone outside for professionals, okay, but we want to let the professional to make a real and precise diagnostic about FASD. I don't know if you are familiar with ARKit. ARKit is a technology that Apple launched last year. It's based in 3D scanning camera. So this mobile phone is an iPhone X. Actually, it can work with any mobile phone that has 3D depth camera. And it is based on flight time. So here you have a 3D laser that launches thousands of small light dots to your face, and we're measuring the time that they fly to your face and return to a detector it has inside. What does this mean? We are getting the 3D shape, real shape of the face in a mobile phone. So that lets us to extend the uses of the technology. To the date, they only use that technology for that, to make emojis. But if they are able to do an emoji, why not to diagnose FASD? I introduce you VisualTEAF. So this is the application, the software we have developed. It is a mix between hardware and software, but actually is quite powerful. This is in collaboration with medical area, clinic with Dr. Oscar, my area, the technology field with my company Neurodigital Technologies, and associative area with VisualTEAF. This VisualTEAF has a lot of projects, different projects, not only that, so I recommend you to enter in the website. I will put in the final slide just to check what are the progresses and what different projects they have. We had a TEAF schedule, so right now we are in the middle with that presentation here in Berlin, and we will start the verification tests during next month in Madrid. The software will be completed with all validations by the beginnings of the next year in January. So let's start. We have developed a facial recognition system. We are based on the HOIME 2016 clinical guidelines for diagnosing fetal alcohol spectrum disorders. And the thing we are doing is just to get all the data input that the doctors are measuring right now, like age, weight, height, head circle, perimeter, and ethnic, and the background. So we must know if the patient has alcohol consumption, had alcohol consumption during the pregnancy, and more other questions we have in next steps. Second step is the 3D scanning. This mask is not a mock-up, so this is a real mask we are generating with our technology, with that iPhone, but it could be any other device. We are using that just because of technology. We have 1,224 points per face. So they are generating in real time. Every mask is different for every patient, and this is a tricky point because we have the real 3D shape, and we are measuring all that parts. You can see that these 6 different sizes for upper lid, philtrum, eyes, and nose. So we are going to focus right now on the eyes, okay, on the eye size, and this is very important. When till date, different other approaches try to use computer vision face to diagnose that, there was a problem. The problem was that these sizes need corrections, because you are using a 2D image to interpolate a 3D measure, because you have a curvature, a curve in the eye. Okay, so we are taking advantage of the technology and using 3D correction through the zero curves and least square adjustments to take into account that, and we have validated every measure with the professionals and real measurements. So this measure about the eye, it's real. And when I say it's real, it's millimetrical real. The other problem till the day was the empirical method validation for the upper lid and philtrum. And this is a problem. Why? Because this is very subjective. So a person must say 1, another might say 2. And this is not very tangible or exact when you want to translate that into technology. So you need precision and exact matches. So instead of having a visual guideline or to introducing subjective diagnosis in the app, we have decided to put artificial intelligence inside and make it possible to learn about the experience or the empirical tests driven by doctors to being able to create dynamic diagnosis with very exact match corresponding to these tables. These tables are from Susan Axley from the Washington University, whom we have a collaboration and partnership to use that data and that information in our application. This is the algorithms, the algorithm or the pipeline in our software. So first of all, we have the data input, where we get or gather all the information presented in the form where you could see before in the application. And second is the training. In the training, right now the application is working. It's uploading all the information to the servers, but instead of designing by itself, we are doing correlations. The correlations we are doing are with people we know that have FASD, so we know what are the real measurements. We are correlating with the measurements we are having, and we are putting that subjective information about the upper lid and the philtrum. So what we are getting with that? We are getting correlations, we are getting great training data, and we are going to learn about that data to be able to generate a dynamic diagnosis based on previous data. Next step is 3D scanning. So this is a new thing because we are having all the data on the cloud. But most important thing is anonymous data. So we are just using 3D masks with no name, correlated with measures, and that is going to be a huge and global database. Just imagine thousands of doctors using that application, uploading data, and it's going to learn. So instead of having only these 10 images, we are going to have millions. We are going to be able to be the most accurate software in the world to diagnose with a simple mobile phone EUFASD. Next step is analysis. Is that task or steps we are talking about with big data and additive data. This additive data is thought about joining more professionals to use that software, and finally the diagnostic. So till the day we are in the step of analysis because the software is learning till we finish with all the validation in January 2019. And this is application itself. Simple as that.